This video will help you to negotiate the solubility graph. This is a graph of the number of grams of a solute that will dissolve in 100 grams of water. And we will try to answer the questions, the 6 questions you see on this page. So let's look at the first question. What is a saturated solution? Northwestern University says it's a solution in which the maximum amount of solute has been dissolved. Any more solute added will sit as crystals on the bottom of the container. The solubility of a substance in water is the number of grams of that substance that then will saturate 100 grams of water. For example, sodium nitrate, NaNO3, has a solubility of 91.2 grams per 100 grams of water at 25 degrees Celsius. Anything short of that number, say 30 grams of the sodium nitrate, will form an unsaturated solution of the salt. It has to get to 91.2 grams at room temperature. What factors affect the solubility of a substance in water? Well, let's look at a couple of them. You'll notice from this solubility graph that there are 8 substances listed, and they have different solubilities at the same temperature. So let's look here at about 30 degrees, and if we look, we see 1, 2, 3, 4, 5, 6, 7, 8 different lines at 30 degrees. And so they have different solubilities at 30 degrees. So solubility is first affected by what it is that you are trying to dissolve, and of course the structure of that substance, for instance whether it's polar or nonpolar. The lines here show ordered pairs of temperature and solubility for saturated solutions of the substance. And it is clear from the graph that solubility for all of these is affected by changes in temperature. First, the blue lines show substances with increasing solubility at higher temperatures. The 2 red lines show substances that have decreasing solubility at higher temperatures. How is the solubility versus temperature graph structured? Well, consider the sugar, sucrose graph that's right at the top of this set of coordinate axes. The line shows for each temperature how much sugar is in a saturated solution. The lines are saturation lines. Any combination of temperature and solubility below that line represents an unsaturated solution. So the solubility lines can tell us not only what is a saturated solution at a given temperature, but what is unsaturated and therefore can hold more solute. What is a supersaturated solution? Well, let's consider the blue curve on this graph, which is of sodium nitrate, NaNO3. It represents, as you can tell, all the solubilities of the salt in saturated solutions between 0 and 100 degrees Celsius. Well, what if we put 160 grams of salt into 90 degree Celsius water, thus saturating it, and then slowly cool it down to 40 degrees without disturbing it? Well, if there is no disturbance, then it's very likely that we will have 160 grams of salt in 100 grams of water, which is way more than the roughly 100 grams that it can tolerate. So we have a supersaturated solution. As you see, the area above the curves represents the area of supersaturation for any salt. Now you have to start off with a saturated solution and then cool it in order to get this to happen. Supersaturated solutions are high energy. They are unstable. Simply adding a crystal of the substance or just bumping it on the table would cause the excess to precipitate out. For example, sodium acetate, which is sometimes used in hand warmers. This is a YouTube video that will show you what it means, and I will add commentary because the audio is not particularly easy to hear. Here is the supersaturated solution of sodium acetate there that has been made, and they did it just exactly the way we said. They took hotter water and saturated the solution and then cooled it down. Now you can bump this or knock it against the table and the supersaturated solute will come out. But what he's going to do is add some of the solute from the bottle that you saw him handling. So all he has to do is add a very small amount of the solute, just 1 or 2 crystals, in order to get the supersaturated solution to become saturated at the lower temperature and discharge all of the additional salt. And as you see, that's what's happening here. That 1 crystal has now grown into what is essentially a whole beaker full of the solid, or not quite full of the solid. And you can see that white substance at the bottom is the excess salt that has come right out of the solution. And then the saturated solution, of course, is above the solid that has been formed. Now, what kinds of questions can the graph help us to solve? Well, a popular test question asks, if we prepare a saturated solution of sodium nitrate at 90 degrees Celsius and cool it to 20 degrees Celsius, how much salt should precipitate out? Well, you just find the 2 solubilities from the curve or from the table from each of the 2 temperatures. And so you can see that at the high temperature, 90 degrees, there is 160 grams that form a saturated solution, but at the lower temperature, 20 degrees, you can only put 90 grams of the sodium nitrate into solution. You subtract to find the difference, which is the salt that should come out of the supersaturated solution. In this case, 160 minus 90 grams is 70 grams of precipitate.